Okay, here's a little potpourri of factoring problems here. Here we have a difference of two squares where this is x squared squared, quantity squared, and this is 9 squared. So here we have a difference of two squares. So it's x squared minus 9, x squared plus 9. We have another difference of two squares here. This is x squared and this is 3 squared. So there's a perfect square here. So this can be rewritten as x minus 3, x plus 3, and then this is not factorable, so it's just x squared plus 9. This next one this is a perfect square trinomial, this term or these three together, and this is just a perfect square. So I'm just going to leave the 9x squared in the front. I'm going to take a negative out of these three. So I get 25y squared minus 10y plus 1. So therefore this is a perfect square, that's a perfect square, and when I multiply those two factors together I get negative 10. So this is 9x squared minus, and then this is 5y minus 1 quantity squared. So I now have a difference of two squares. So the square root of that is 3x, the square root of that is 5y minus 1, and then 3x minus the quantity 5y minus 1. So I don't need the parentheses here, so I'm just going to rewrite this as 3x plus 5y minus 1, and I distribute the negative here, 3x minus 5y plus 1. Number 3 is similar. Except in this case I messed with the order just to mess with you. So here's a 12x, here's a 4x squared, so those two clearly need to go together. So I'm going to put this 4x squared up front. So I get 4x squared plus 12x plus 9 minus 64y squared. Here's a difference of two squares. However, if I'm just left with these two, the only thing I can do is take a greatest common factor out, and I'm not going to get anything the same because there's a y's are here and x's are over here. So if I consider this a perfect square trinomial, where this is a perfect square and that's a perfect square, so 2 times 3 is equal to 6, and double it, you get 12. So therefore this is 2x plus 3 quantity squared minus 64y squared. So notice in this one, I took all the x's and put them together, and then it turned into a trinomial, perfect square trinomial, which is a classic problem. So here's the difference of two squares. So I get 2x plus 3 minus 8y, 2x plus 3 plus 8y. And my final problem is, here's a perfect square trinomial, and here's just a greatest common factor of a. So this perfect square trinomial is a squared minus 4 quantity squared. And if I take the greatest common factor out of negative a, I want a negative a because I need a negative 4 and I need a positive a squared. So take out a negative a, I get a squared minus 4. So I now have a greatest common factor of a squared minus 4, or factor by grouping, a squared minus 4. And then I'm left with a squared minus 4 minus a. So there's nothing I can do with this. And this here, I'm just going to rewrite the order, and then I'm all done. So this would be a squared minus 4, a squared minus a minus 4. Are there any factors of 4 that add up to negative 1? No, it's just 1 and 4 and 2 and 2, so that doesn't work out. So that's the end of this short video on factoring.